Okay, well, good morning, everybody. We are really excited that you've joined us. We are going to be talking to you a bit today about controlling the temperature and the humidity in your greenhouse. I'm Kelly Nicholson, and I'm here with Kevin Blackmore, my coworker, teammate from New Zealand. We are on separate continents right now. I'm here in California, and he's actually in Auckland. So yeah, we're excited that you are joining us. Before I forget to mention it, on the bottom right-hand side of the go-to meeting panel, there is a spot for questions. So any questions that you have that come up throughout the webinar, please put them in, and we will be answering them all at the end of the webinar.
Okay, so just to give you a little bit of information about us. So my co-presenter is Kelly Nicholson. She's a sales director for Controlled Environment Agriculture. She's got a Bachelor of Arts in Communication. But the biggest thing, she's had 17 years in the hydroponics industry. She's served large multi-acre farms all the way down to small home gardeners, and she's been doing on-site training, installations throughout the USA, Canada, New Zealand, Australia, and all around the world, in fact.
And Kevin Blackmore is our current product manager for Autogrow. He has a Master's of Engineering Studies from Auckland University of Technology. He's got 18 years with Autogrow, so he just has a little tiny bit more experience than me, and he reminds me constantly of that. He's been a design engineer, an R&D manager, and a product manager. He was the lead designer of our IntelliDose and IntelliClimate product line, as well as our MultiGrow product line.
And just a little bit about Kelly. She's a passionate rugby fan, and she's really passionate about our New Zealand team, the All Blacks. So if you ever run into her, say go All Blacks, or give her a silver fern, and she'll love you forever.
That's probably true. So who is Autogrow? So established in '94, Autogrow is committed to creating and providing the most amazing solutions we can come up with to solve the world's most difficult problems in producing crops. So we believe growers should have affordable, accessible, and easy-to-use innovation 24/7 anywhere in the world.
Yeah, so we've got a global headquarters down in Auckland, New Zealand here. We've got growers and resellers in over 37 countries around the world. We're trying to provide intelligent hardware, software, and data solutions, for large-scale, fully automated greenhouses and warehouses, all the way down to the single compartment, small operations. We have a team of software designers, engineers, horticultural experts. We're trying to push the innovation boundaries to gain the best results for you guys, the growers.
So let's get started. Let's talk about controlling temperature and humidity in your greenhouse.
So the first question, I mean, temperature and humidity is a huge topic, and there are so many different aspects of it. But what we're going to try and do is sort of narrow down into a few key areas. But the first question everybody asks is, why is managing temperature and humidity important?
Well, first off, it's really important for managing pests and disease. So plants that are not kept within their ideal kind of growing environment, they get too wet because the humidity is too high, or they get too hot because it's not able to cool down fast enough, will create a stressed plant, and stressed plants are more prone to get pests. Also, plants that are wet and are in too humid of an environment, they can get molds and mildews, which will make your product not able to be sold.
Yeah, and I mean, a strong and healthy plant has a natural defense against a lot of those pests and the molds and mildews, and so managing the environment, keeping them happy and healthy is really important to maintain healthy plants. The other aspect is encouraging the plant performance, or altering the plant growth stage. So by having a really good temperature and humidity for the plants, you can increase the transpiration rate of the plants and get the nutrient uptake increased, and that way you'll get tastier tomatoes and a more rapid production of the yield. The other aspect is you can steer the plants to particular growth cycles. So by adjusting the temperature and the humidity of the environment, you can steer the plants to the vegetative stage and then back to the fruiting stage, and that's really important for those longer term crops.
Yeah, a great example of that is strawberries. So strawberries like to get really cold before they actually create flowers and fruit. And so a lot of strawberry growers will actually chill their strawberry plants, getting them very, very cold, almost putting them through a freeze, and then immediately warm them up. And as soon as they warm up, you'll see that strawberry starts putting out flowers, which of course turns into the strawberry fruit. So what are the challenges of managing temperature and humidity? I mean, there's quite a few, but we just had to choose some of the big ones. So one of the biggest challenges in managing your temperature and humidity in a greenhouse is consistency. So it's really important that you want the temperature and humidity to be managed throughout the greenhouse equally, and that we don't end up with microclimates. You don't want little pockets of real humid hot air in certain parts of the greenhouse. So it's important that it's consistent throughout.
Yeah, and I mean, as I said before, by keeping good management of the temperature and humidity, you can control the transpiration rates of the plants. So you can keep them in that comfort area where they're performing at their best. And by keeping the humidity right, you can increase the evaporation of the moisture on the leaves. And if you're not managing the humidity well, then what you can do is actually get condensation form on the plants or on the fruit or in the walls, and that's a breeding ground for diseases and the mildews and what have you. And you know, having dew form on the tomato or the fruit itself, that can cause detrimental effects, splitting fruits, all sorts of other things. So management of the temperature humidity is really important.
Yeah, and then of course there's always outside influences to think about. So if you are in a really dry, arid climate, of course bringing in hot, dry air into a greenhouse where you're growing a crop that needs it to be a bit on the more humid side, you have to manage that, as well as bringing in, you know, cold, wet air or hot, you know, humid air. So knowing what's happening outside of the greenhouse is really important, as well as knowing what's inside of the greenhouse. So are temperature and humidity exclusive? And no, they are not. Every time that you adjust the temperature, you're going to have an effect on the humidity and vice versa. So for some growers, it's really important, you know, that you can actually heat up a greenhouse. And by letting the greenhouse get a little bit warmer, you can build up your humidity. You can cool it down a bit to lower your humidity. A lot of this, of course, is location dependent. But every time that you adjust your temperature, you know that the humidity will also adjust.
Yeah, and I mean, plants feel things differently than humans, and what keeps them comfortable is the transpir. You know, what keeps them running is the evaporation of the moisture from the leaves. And what's a measure that helps us determine that is the vapor pressure deficit. The vapor pressure deficit is essentially the difference between the amount of moisture that's in the air and how much it could carry. And that affects the speed at which, you know, the moisture can evaporate from the plant. If you're looking at the little chart at the bottom of the screen, you can see there's a little green zone, and that's the sort of comfort range for most plants. The ideal sort of VPD measurement is about 0.85 kilopascals or 8.5 on the chart below, but you can see it spans quite a wide range of humidities over a wide range of temperatures, and so trying to keep it in that zone, it will keep your plants, you know, happy and healthy.
Yeah, absolutely. I mean, as you can tell, that perfect ideal, you know, VPD is right around the 68 to low 70s degrees, right around that 65% humidity. It can be a challenge to stay there, but it's really important that you aim for that. Kevin and I just recently visited a grower who was having some wilting issues with their leafy greens, and when we looked and we saw that their VPD was really low, we were able to make some adjustments to some of the settings with the different equipment that they use to control their VPD, and we're able to bring that VPD up to make the plants a little happier and healthier, and so they stopped wilting. So is there a one-size-fits-all solution? And of course, there never is a one-size-fits-all solution, because growers all over the world use many different methods to control temperature and humidity in their greenhouses. Depending on where you're located, you're going to have elevation differences. You're going to have, you know, the temperatures outside, your humidity levels will be different. You know, somebody who's, you know, near the equator is going to be usually very humid and hot, where somebody, you know, in the northern hemisphere, you know, northern Canada, dry and cold. A grower in the Bahamas is going to have heat and humidity issues, and a grower in Colorado is going to be cold and dry.
Yeah, and I mean, it's not just environmental things that affect, you know, how you control these things. Economics plays a big part in it as well. In some areas, you might get subsidized electricity or subsidized gas supply, and that can affect dramatically how you attempt to control these elements. Subsidized gas means you may get a gas burner. Subsidized electricity may mean you go for an electrical method. And so all of these things come into play when you try to determine what the best solution is for your particular growing area.
Now, greenhouse design. So, if you're lucky enough to be building a greenhouse from the ground up, which is awesome, you have a lot of decisions that you can make about how to design your greenhouse. For a lot of growers, you're actually retrofitting a greenhouse that's already existed. So, sometimes you don't get to make these decisions. But in the ideal world, if you were able to design your own greenhouse, greenhouse height is one of the biggest issues that can be based on the crop that you're growing.
Yeah, I mean, a taller greenhouse typically will have a larger air buffer above the crop, and that allows you to get a much more smooth control of the temperature, humidity. It makes it a little bit easier to manage. And that's something you should consider. I mean, you may not be building a greenhouse, but if you're looking to lease one or something, this is something that you should really look at. How much area is there going to be above the crop to allow you to get that buffer space? If you are building a new one, there are a lot of new innovative techniques that you can use to try and be economically managing the temperature humidity. One of them is, as we've got in the picture on the right, is the ground to heat air heat transfer system, where essentially you're using your own environment to control the temperature and humidity.
Yeah, I mean, if you take a look at those pictures on the right, this is a really cool system. I mean, we all know that the temperature, in the soil underground doesn't vary like the temperature above ground does. And so it's usually a very just kind of a moderate temperature, like you see here in the charts, 50 to 70 degrees. So during the day, you actually take the hot air from your greenhouse, you push it down through pipes in the ground, and when it comes back into the greenhouse, it'll be nice and cool. At night, when it's cold in your greenhouse, you push the cold air down, push it through the same soil, which will actually warm it up, so then you put warm air into your greenhouse. So you're actually using your own greenhouse environment to control your greenhouse environment, which is awesome. Also, location, wherever you put your greenhouse, making sure that you understand, where the best location to put it is on the side of a mountain or, at the base of a hill or, out in the middle of a flat field, kind of based on where you are.
Yeah, I mean, the wind that you're getting, the type of rain that you get, all play key, they're all key elements to picking a location. Also, the amount of light that you're going to get, that's a key element as well.
Yeah, absolutely. So now we're going to just talk about the different equipment that growers will use to maintain the temperature and humidity in their greenhouse. So the first thing is fans, and the most popular fans used in greenhouses are the HAF, the horizontal airflow fans. So basically, these fans are mounted throughout the greenhouse, usually hanging from the roof, as well as on the sides of the greenhouse, to make sure that there is a lot of air movement. This will also eliminate those microclimates I mentioned earlier, and they're fairly cost effective. It's not a real expensive thing to run, but it will get you the air movement that you need.
Yeah, I mean, by keeping a consistent environment across the whole crop means you're going to be getting a consistent growth rate, and you're not going to have plants at different stages when you don't expect it. And it's difficult to overstate the importance of these HAF fans. They may be the single most cost-effective method that you put in your greenhouse to keep the plants consistent. The other type of fan that people use are extraction fans. And so as you can see in the photo there's a bank of fans along one wall, and these are used to actively cool the greenhouse by drawing the air from the outside of the greenhouse into the greenhouse, and that will essentially exchange the air from within the greenhouse with air from the outside. This can cool the greenhouse, or it can reduce the humidity if it's dry air outside, and they just bring in lots and lots of air, and it has a massive effect on the humidity because you're just switching it all out.
So then vents. So obviously vents are very popular in greenhouses. It's important, and I'm going to mention it again, whenever you have a greenhouse, it is important to know what's happening outside of the greenhouse as well as what's inside of the greenhouse. So whatever automation solutions you choose, you always want to make sure that you have a weather station. So a weather station is not only monitoring the temperature and the humidity outside, it's also measuring your solar levels and has the capability of measuring rain and wind direction. So as you can see in this picture of the greenhouse down on the bottom right, it's really important, if that roof vent is going to be open, that we know what direction the wind is coming in and how fast, because you don't want to blow a vent off the top of your greenhouse. It's been known to happen. So it's really important that when we're making decisions about opening and closing greenhouses, that you know what's happening outside of the greenhouse before that decision is made.
Yeah, and I mean, ventilation using a roof vent or a side vent is a passive cooling method. It's using the natural convection of hot air. Hot air rises, And so the roof vent is usually the most efficient way of cooling a structure if you're in a temperate climate. So the hot air rises to the top of the greenhouse, goes out the vent, and it draws in some cooler air underneath that. And we just control that by proportionally adjusting the vent opening. Open it further if you need more cooling. Keep it closed if you're trying to trap humidity in, perhaps, so that you let the temperature increase, get that VPD in the good area. And the another type of vent that is often used are the side vents or roll-up walls. These can be used to protect the plants, but still increase the airflow within the greenhouse. So if you've got your plants up on a bench, if you roll the side walls up to the bench height, you've got lots of airflow underneath the benches, but the plants are still screened from the outside environment.
Yeah, absolutely. And this allows you to use like an ideal weather condition outside to be able to cool down the crops. So if you've got just a nice breeze and it's cool outside, rather than turning on fans and using electricity to cool it down, you can just roll up the sidewalls and let that breeze just go right through the plants. So wet walls, now just in case you're not familiar with how a wet wall works, I'll keep it really simple. What you're seeing here in this picture is kind of a classic wet wall. There's a gutter across the top that has water in it that trickles through the wet wall and back down into a collection pipe, where it then goes through a filtration system and recirculates all over again. And so this is a really kind of great way to affect your cooling and the humidity in a greenhouse.
Yeah, I mean, this is a very active cooling method. So you use this in combination with an extraction fan. So you'll have a bank of wet walls along one side of the greenhouse. On the opposite side, you'll have a bank of fans to draw the air through the wet wall, and the water that's dribbling down and wetting that cooling cellulose material will evaporate off and give you up to 10 to 15 degrees cooler air on the inside as it came from the outside, just from the fact that you're evaporating the water from the air. So this is a really cost-effective method of cooling in an area where it's, might be arid, or sometimes like where you might just want a few degrees cooling. And it's just important to say that the material that they use there is a cellulose material. It's specially treated to give you, to resist degradation and the buildup of moss and what have you. And it gives you a really good evaporation rate. Of course, the side effect of evaporating water is that you're going to get an increase in humidity. And so it's important when you're doing a wet wall cooling solution that you're also managing the humidity, making sure that you cut off the water supply to the wet wall if the humidity is getting a little bit excessive.
Yeah, and it's also, it's a great addition. So we have a grower in Las Vegas right now where we know it's very dry in Las Vegas. You're at like 20 to 25% humidity, it seems like most of the time, and it can be very, very warm. So they really need to cool the greenhouse down, but they need to add a lot of humidity, and the wet wall is just a really efficient way of doing that.
Yeah, and I mean, what you can do is actually pair those two together and get a hybrid solution where you're using a natural aspirated vent during the evening when it's cooler, and a wet wall for active cooling during the day. Just a question from Shirley Plant is that she asked whether it was in Fahrenheit or Celsius, and it's actually in Celsius was what I was talking about.
Thanks for the clarifications. Now we're going to talk energy curtains. So energy curtains, as you can see in the picture, are curtains that will roll out over rails above your crop. One of the best things about being a greenhouse grower is that you get to utilize the solar energy, and you're not paying for light because lighting is very expensive. The problem is that depending on the crop you're growing, sometimes you have too much solar energy. For example, leafy greens in the middle of the summer, in the middle of the afternoon in a really hot area will start to transpire too quickly if they have too much solar energy, which can create tip burn and whatnot. So we want to actually control the amount of solar that's allowed to the plants. So by using shade screens, we can control the amount of solar that the plants are getting.
So I mean, one of the things that you can choose when you're picking your energy curtain is the weave. So a looser weave in your energy curtain, if you're having excessive humidity problems, a looser weave will let the humidity transfer through the screen and get vented out through the roof vents if that's what you're using for your cooling. And if you're having issues with trying to control the temperature. You might use a tidal weave to trap that temperature and humidity within the greenhouse. So in a lot of cases, you may pull the energy curtain across just before sunset to try and trap some of that free energy you're getting from the sun and offset your energy costs for heating the greenhouse later on in the day. One of the things that people don't often think about when thinking of the plants is on a clear night, the plants are essentially exposed to the deep cold of space. So a plant is essentially a radiator. It collects a lot of solar energy. It's got a huge leaf area, and those leaves, when it's a clear night, they're exposed to the deep cold of space, which is minus 270 degrees Celsius, and that will actually cause the plants to become a little bit stressed. The leaf area will be cooler than the air around them, and a way to reduce that stress is to pull the energy curtains at night, even though there's no sun out, just to stop the exposure to space and stop them getting overcooled.
So then there's hydronic heating. So this is another method of heating your greenhouse, and this is a really effective method that a lot of, especially vine crop growers, will use. You'll see it in a lot of tomato greenhouses and cucumbers and whatnot. So hydronic heating is where you have a boiler that will keep water very, very hot. That is then controlled via valves to be sent through these metal pipes like you see here in this picture, and that will actually heat up the pipes, which then of course emits heat into the greenhouse.
Yeah, so essentially what we're doing is we're pumping that hot water through those pipes. In this case, those pipes are serving a dual purpose. They're using it as a rail for their lifts, but by controlling the temperature of the pipes, the water in the pipe, sorry, we're able to actually affect the air temperature. So at night we'll increase the pipe temperature and get an effect in the ambient heat of the air around the plants, and that's one really effective method and efficient method of getting heating within your greenhouse.
There's also root zone heating. So for nurseries and for propagation type systems, it's really important that you keep the root zones nice and warm. So you'll actually see these rails will be lifted up off the ground. They'll be more at like bench height, and they'll run underneath the benches. So the bedding plants and the propagation, the seed propagation trays will sit on top of the tray with the pipes below it.
Yeah, and I mean, what a lot of growers will do is they'll actually keep the pipe temperature a few degrees hotter than the ambient air around them, and that way you're actually forcing, convection of the air. The heat's going to rise up through the plants, and that's going to make the plants work harder, drive the transpiration rate, uptake more nutrients in the system, and that's just a method of sort of boosting the performance of the plants just by keeping those pipes, the water in those pipes, a little bit hotter than the air temperature around them.
So as we've been talking about getting rid of humidity a whole lot in this, but for some crops you actually need to add humidity. So it's like baby plants, microgreens, vegetative plants, and early veg, they can't be very dry. And so depending on your location and of course your environment, you may need to actually add humidity to the system. So a really low cost kind of entry level humidity control is overhead misting systems, where you basically just mist over the entire crop. The problem with a misting system is that you can get large droplets of water that can actually damage the crops. Large droplets of water on leaves of a very like a baby microgreen type plant would damage it.
Yeah, and if that's a possible problem, or if you're after a more high performance system, you can go for like a high pressure fogging system. So essentially, they've got a really high pressure through the pipes, and it's got tiny little nozzles which create micro droplets in the air. So it's essentially creating a true fog rather than water droplets. So this will increase the humidity if you're trying to do humidification within the area without having droplets form on the plants, but it also is a really effective method of cooling, because those micro droplets will evaporate very quickly, and you can get a massive impact on the amount of cooling within that environment. One of the things that you need to think about though when you're picking a fogging system is to make sure that your automation system has an understanding of both the humidification effect and the cooling effect. Because if you're trying to humidify your environment, you need to make sure that you're not bringing the temperature down too much that you're going to detrimentally affect the plants, and vice versa. If you're trying to cool your environment, you don't want to have the humidity build up so much that you're going to start blocking the transpiration rate of the plants as well.
Yeah, and you can use fogging systems with energy curtains. So if you have, if you're in a really warm area and you're actually using fogging to cool the plants down, as well as to humidify the environment, you can pull your energy curtain over the fogging system and then fog below it, so that it doesn't evaporate quite as quickly, and you can actually keep that effect of the fogging system on the crop for longer.
Yeah, and I mean that would mean that you've picked a like a tighter weave energy curtain, so you don't waste a lot of that vapor that you've created. But it's a really efficient method of reducing the volume that you're trying to manage.
So that wraps up this part of the webinar. We are going to be doing another webinar in about 6 weeks, and I'm sure you can tell from the crop that we've pictured, it's going to be December. We are going to be going into more advanced greenhouse controls. So this webinar was to kind of give you an overall view of the equipment that's used on the average greenhouse, but there's a lot of innovative techniques that are going into growing plants, and we want to get a little bit deeper into those. So we're going to be talking more about the vapor pressure deficit. A topic I'm really excited about is talking about CO2 in greenhouses, because it's a bit of a people haven't quite decided if it's worth it or not, and I have some views on that. Also, supplemental lighting, blackout curtains, and we're going to go a little bit deeper into actually the root zone environment.
Yeah, and I mean, if you look at the crop that we've got pictured there, the poinsettias, in the southern hemisphere here, we can't actually grow those and get them deliverable for Christmas without the use of blackout curtains. And similarly, I think in some places in the northern hemisphere, they can't do the same without using supplemental lighting. So it's a really good picture for what we're going to be talking about next.
Yeah, so definitely, keep an eye on your emails, Facebook, all of that. We'll be letting you know once we've got an actual date picked out for that webinar. So, we really appreciate you guys taking the time with us. We're going to get to questions in just a second here. But I wanted to just remind you, we're really excited to hear about your projects. We know that every one of you has unique ideas and you've got plans, and we would love to be on the same page with you, hear all about it. You can go to offer.autogrow.com, which is also linked down in the chat section of the GoToWebinar panel. And you can give us all of your information, and one of us will reach out to you. Feel free to call us at any time. You can find us on Facebook, Twitter, LinkedIn, just autogrow.com. We love hearing about what you guys have going on and seeing how Autogrow can offer up automation solutions.
Yeah, and don't forget to like us on Facebook, LinkedIn, Twitter, and what have you if you like the the webinars and you want to see more of them. So on to the questions. So I had a question that I'd just written myself. That I thought would be a good starter for this. So the first question that I had for myself was, where should I locate the sensor? Where should the temperature humidity sensor be in a greenhouse? So
yeah,
sorry,
so it's really important that when you're placing your environment sensor, you'll see a lot of times that environment sensors are like mounted to walls or mounted to posts, and they're really high above the crop. Well, it's not so important to understand what is happening 7 feet above the crop. It's really important to know what's happening in the canopy of the crop. So I recommend putting your sensors as close to the canopy as you can get. We want to know what the temperature and the humidity are, the light levels right at the crop, not what's happening on a post, way above it.
yeah, and if you've got a large greenhouse or a large growing area, having multiple sensors to get an average around the whole growing area is also quite important. And so you're getting a better feel of the whole environment rather than just the little microclimate you might be looking at. I had a question from Daniel. He's asked, what would be the best way to add humidity, a warm mister or an ultrasonic? So as we said in our slide, there are, in a greenhouse, typically we'd be using a high pressure fogging system or a misting system, but again, it really does depend on your specific requirements and your size. So like a ultrasonic type solution or a warm misting solution, that may be really cost effective in a smaller operation, but when you get to those larger operations, you kind of need to go for a specialized solution, something like a high pressure fogging or a misting solution.
And I also noticed, Daniel, that you asked if we had a distributor in Africa. I know that our teammate Peter is managing the Africa market, so if you'd like to reach out to autogrow.com, you can just go to sales@autogrow.com, and we can connect you up with him so that he can get you in touch with a reseller.
Yeah, and so the next question is from George. He's asked, energy curtains on leafy greens on a hot summer day, if they're fully open, does it affect the ventilation? So the energy curtains, depending on what weave you've chosen. I mean, if you're growing leafy green in a temperate climate, you've probably got a loose weave shade solution, in which case the air and the temperature and humidity is sort of passing through, and it's more just affecting the amount of light going to the plants. Of course, if you're trying to reduce the area, it will of course affect the ventilation. But your control solution, quite often, like with our systems, we allow you to crack the shades, the energy curtains a little bit to let humidity and temperature sort of go around the shade curtains when it's becoming an issue, and that can be one way of managing the air transfer for the ventilation.
Asking if there's a database where you can find out optimal humidity and temperature values for different plants at different stages of growth. Google is my first thought, but there's a bunch of different reports and studies that have been done by a lot of different universities, and so that's probably where I would start, is finding out the crop that you were growing, tomatoes in, late stage, bloom, whatnot, and try and find out the VPDs for those. There's a few books out there too, written by some of the Kiwi counterparts that actually have some great charts in them. That you can find online also. I think hydroponic crop production has a lot of EPD requirements for different hydroponic crops.
So a question from Spiros Pita, sorry if I pronounced that incorrect. How do you deal with dropping the temperature in a high humidity area, say circa Florida in the USA? So in a high humidity area, you can still use those wet walls. They're an active cooling method, but what you might need to do is like a hydronic cooling solution. We talked about hydronic heating, but you can also pump cool water through those pipes as well if you're dealing with too much heat rather than too cold an environment. So that's one possible solution. The other possible solution is to do some more active dehumidification, sort of seal off your greenhouse, recirculate the air, and try and dehumidify it a little bit more. So there are different techniques you can use. It all depends on the type of structure you're using and what you're trying to achieve.
And then we've got a question from Ricardo, who's asking if the Autogrow equipment is able to handle light and climate. And yes, so all of the Autogrow equipment is designed to manage the full climate of the environment. So all of the equipment that we talked about today is managed, as well as top-up or supplemental lighting, and the rest of the equipment that we'll get into in the next webinar. But yes, all of the Autogrow equipment can manage all of it.
A question from Peter: how can I track my temperature history and make adjustments to my growing technique based on this data? So depending on your size, you may employ consultants to assist with the day-to-day, well, not the day-to-day, the overall decisions you're making with your system. But with all of our equipment, we do on a lot of data logging on the controller. We don't throw any of that away, so you can compare from season to season. And having that history, I mean, growers live and die by their graphs. So having a system that monitors and logs the temperature overnight when you're off site, and you can go back and review that, is really important, and it helps you fight a lot of different issues that you have in the growing area.
So there's a couple different. Oh, I'm sorry, I didn't mean to cut you off, Kevin. One of you pointed out that if you're on an iPad or on like a tablet, that it's actually just a question mark, so it must look a little different than the laptop. So if there's questions that you have, then click on the little question mark. We've got another question about, is it important to put the humidity and temperature sensors at the canopy or the roots, or both? And I'm going to say both, but there's sensors that manage the environment, the aerial environment. So there's sensors designed to manage the air's temperature and humidity, light levels, also CO2. And then there's actual sensors that are designed to manage the root zone. So there's moisture sensors, temperature sensors, EC sensors that can actually go into media to manage what's happening in the root zone. So ideally, you would have both types of sensors so that you would know what was happening at the root zone as well as in the environment.
Yeah, and in some cases you can't actually measure what's happening in the roots. I mean, if you're growing in a media or in a substrate, then it's possible to use those probes. But if you're using a NFT technique where you've got gullies like in the photo in the back, you can't actually measure what's happening at the root zone. But what you'll do is measure what's happening in your reservoir, and you'll be able to get a really good look at what the EC and the pH is of the root zone. Also, controlling the temperature is really important in that type of a situation. So keeping the temperature at the ideal level for the crop. So you may have a chiller or you may have a heater to keep that solution. So that's another area where you can do measurements.
Yeah, absolutely. So I think, oh, let's see. Did you want to answer Peter's question? We got one more that popped up, Kevin.
Yeah, so Peter's asked, do you have any thoughts on roll-up walls versus vents for passive cooling in a temperate environment? So for me, the first choice is always going to be a roof vent. That all of the heat, the convection means that the heat's going to rise, and so you're going to get the most efficient exchange of hot for cold air through a roof venting system. The sidewalls will be able to assist if you've got like a nice breeze coming through. So that, as we said in that slide, that it lets you utilize sort of open it up to the ideal environment if you've got it at that time. So we have a lot of people who just use roof vents because they've got quite a delicate crop, say a flowering crop. Sorry, they're growing flowers, not a flowering crop. In which case they don't want to sort of let any breeze come in and affect the crop, so they'll just be using a roof cooling mechanism, maybe a wet wall with a gentle breeze coming through. But the side vents are also quite good for places where you've got a prevailing wind or a nice breeze.
I think that we've got all of our questions answered now. I mean, I really appreciate, I'm sure we both really appreciate you guys taking the time with us this morning. We had a pretty good turnout, and I hope that you all were able to learn a bit. Please feel free to reach out to us with any kind of direct questions about your project, and we look forward to seeing you back here in about 6 weeks when we do the more advanced greenhouse controls.
Yeah, thank you very much.
Okay, have a good afternoon, everybody.
Goodbye.